Hello everyone, I wanted to start my presentation by thanking the ICI2C team. So I will present our paper entitled COBIT 5 Concepts Towards the Development of an Ontology Model, realized by Lamia, Moudoubah, Yamami, Khalifa Mansouri and Mohammedia. So according to the ICI2C 2019 reports, we can talk about governance without going through the methods of putting an information system under control. So based on our knowledge, COBIT is the only framework that includes the latest developments in information system governance and management. It provides principles, best practices, models, and analysis tools to increase information system confidence and value creation. So while reviewing the literature, we noticed that there is a lack of formalization of COBIT 5 concepts. So to overcome this lack, we propose in this paper an ontology formalized the COBIT 5 framework to facilitate its implementation for professionals. So this observation gave birth to our research work, which leads us to present in this presentation 4 principal parts, which are the previous works, the methodology used, the proposed ontology, and the conclusion. In addition, the perspectives for our future works. Our motivation to formalize the concepts of COBIT 5 frameworks was based on solid criteria. So COBIT 5 is an integrator of good practices in information technology and the general framework of information system governance that allows understanding and managing the risks and the benefits associated with them. So COBIT 5 best practices are the result of a consensus of experts. They are very much focused on control in the sense of mastery and less on execution. They are intended to help optimize IT investment, service delivery, and provide metrics to refer to when monitoring performance. So COBIT 5 is continuously updated and harmonized with other standards. In this contribution, we built our ontology through textual analysis of the domains and the extraction of its main concepts and relations based on the documentation of COBIT 5 framework of ICI2C. This operation is performed by term frequency and inverse document frequency method. The terms extracted by TF and IDF statistical analysis were presented in the UML metamodel, and then we used the UML to OL transformation. Then we analyzed the possible rules of an ontology to arrive at the representation of the OL model of our, of course, proposed ontology under the protégé tools. For the first step, as the starting point, we studied the existing terms in the COBIT 5 framework documents in order to extract all the questions that this ontology can answer in the context of IT governance based on COBIT 5. So these questions are the following: how to achieve a better alignment of IT with the company's business because of its business orientation, how to have a management understandable view of what IT does, how to give a clear distribution of ownership and responsibilities due to the process-based approach, how to get a good orientation from third parties and regulators, and how to have a shared understanding by all stakeholders throughout a common language. Then we apply the statistical analysis, which generally consists in studying parameters that indicate the frequency of appearance of term of this term and the term candidates in the corpus. So TF, this number is usually normalized by the total number of terms in a document. Term frequency is used here to identify relevant terms in a corpus, so to identify candidates, concepts, and relations, and to distinguish among the terms those which will become classes or properties of our ontology. IDF is calculated by the following equation, where the denominators is the total number of documents in the corpus, and the denominators denotes the number of documents where the terms T appears. So to determine the denominator D, which is the number of documents, we must mention that the chosen corpus is composed of different books of ICI2C that deal with COBIT 5. We use the concordance and count of corpus analysis for concordance and the text analysis. The analysis of the corpus in the concordance is done by depositing the files that make up our corpus into the software. Then we use the filter of terms of our ontology and detect their frequency of occurrence in the selected French corpus. So the result of this statistical analysis is exposed in this table. Our UML metamodel represents all the concepts resulting from our statistical analysis. So implementing COBIT 5 would require an updated data model specific to the IT department designed with the IT governance in mind in order to achieve the governance objectives. So IT governance is the command and control structures and processes that drive enterprise IT to support business strategies and objectives. The main objective of COBIT 5 processes is to ensure that the IT infrastructures and the objectives are detailed. So for each process we detail the associated objectives. We also detail the associated metrics. So each process area contains objectives to be achieved, as well as a description of the practices that will be used. So as a repository for information systems company, the process is a set of correlated activities that transforms incoming elements into outgoing elements, the activities themselves being described in procedures. COBIT 5 provides key performance indicators and key success factors for each of these processes. So the company is the entity concerned by the COBIT 5 transformation. The implementation life cycle included in COBIT 5 is an excellent approach to address the complexity and the challenges typically encountered in any transformation project. So the implementation life cycle of COBIT 5 defines 6 categories of enablers that are policy, service, information, structure, people, and culture. Both the unified modeling language and the web ontology language are used for conceptual modeling. So according to the literature studied on OOL conceptualization, we summarize that OOL has had difficulty gaining acceptance. As a result, academic research has attempted to exploit exciting UML models by automatically transforming them into OOL ontology. So there is no consensus on how UML should be transformed into OOL. However, by analyzing previous work, we could deduce that most studies focus only on transformation between UML and OOL. In this contribution, we made use of an UML to OOL transformation based on the results of mapping between UML and OOL components established recently in 2019 by Sadowska and Husser. and this is a high level, of course, of mapping. So to explain this overview, an UML classes is mapped to an all classes. So for each UML classes is an UML package, and UML declaration axiom of an all classes is added to an ontology, and the UML attributes has a UML property as type. Both UML and OL have constructs to represent properties. Properties are mapped to all objects and data properties depending on the type of the property, and this type is a complex data type when a data type has owned attributes. So type is classes and objects property is used in the mapping. So the mapping applies to all components of our UML meta model following the rules mentioned in the following table. So we respected all these rules of mapping to transform our meta model UML into OL ontology. So this slide presents an overview of the developments of our ontology under Eclipse, which is then formalized under Protégé tools, and thus the OL ontology manager is the central class for the management of our ontology. It manages the creation, the loading, and the saving of ontologies, the applications of changes such as annotations or axiom additions. We then develop our code to create our OL ontology in the Eclipse tool. So the results were presented in Protégé tool. In order to view the concepts of our ontology, here is an overview of the classes and the relations that make up the proposed ontology. So to validate our ontology, we rely on a set of questions that we used Hermit inference engine integrated in Protégé 5 to answer in order to validate the structure of our COBIT ontology. So here we have the inferred classes generated after applying the reasoning on the concepts of proposed ontology. So the result of our contribution is an ontology validated by the Hermit inference engine and checked thanks to an extension of the ontology editor OntCheck, which aims at verifying or checking the respect of naming convention as well as the completeness of metadata. The OntCheck plugin allows to define cleanup checks on generated OL ontology to be stored and performed before each ontology publication, so test violation found can be corrected to promote consistency in entity naming and the meta annotation. So we used the OntCheck plugin to test our ontology. By activating the OntCheck plugin, we were able to perform tests on all concepts that make up our ontology. So to conclude our contribution, we can say that the governance involves the assessment, direction, and monitoring of the current and the future use of corporate information system. It involves taking into account the impact of business decisions and the activity on society, the environment, and the economy. COBIT 5 enables and promotes structured approach to the necessary assessment and decision processes. Our contribution aims to overcome the lack of an OL model structure and expert knowledge related to the information system governance domain, and specifically to the COBIT 5 framework. My presentation is coming to the end, and thank you for your attention.